Hello and welcome back at the Finetlink channel. And after we saw all the LAN security concepts, now as part of your responsibility as a network professional is to keep your network secure. And most of the time we only think about security attacks coming from outside the network, but threats can come from within the network as well, because these threats can range anywhere from an employee innocently adding an Ethernet switch to the corporate network so they can have more ports, or to malicious attacks caused by disgruntled employee. It is your job as a network administrator to keep this network safe and ensuring that business operations continue uncompromised. And what we will see here in this material is about switch security configuration, where we will implement port security to mitigate MAC address table attack. We will explain how to configure dynamic trunking protocol and native VLAN to mitigate VLAN attacks. We will explain how to configure DHCP snooping to mitigate DHCP attacks. We will explain how to configure ARP inspection to mitigate ARP attacks, and then we will explain how to configure port fast and BGU guard or bridge protocol data unit guard to mitigate spanning tree protocol attacks. And in this material will be divided in two videos, and in the first one we will only do the implementation for port security to mitigate MAC address table attacks. So let's dive in. You have to understand that layer 2 devices are considered to be the weakest link in a company's security infrastructure. And layer 2 attacks are some of the easiest for hackers to deploy, but these threats can only be mitigated with some common layer 2 solution. All switch ports should be secured before the switch is deployed for production use. How a port is secured depends on its function. So a simple method many administrators use to help secure the network from unauthorized access is to disable all unused ports on a switch. For example, if you have a Cisco Catalyst 2960 switch who has 24 ports and there are 3 fast Ethernet connections in use, it is good practice to disable the 21 unused ports. You have to navigate to each unused port and issue the Cisco IOS shutdown command, or if a port must be reactivated at a later time, it can be later with no shutdown command. So, in case you need to configure a range of ports, you use the interface range command as it is here. For example, here we want to shut down ports from Fast Ethernet 08 through Fast Ethernet 024 on switch 1, and then you have to enter this following command: interface range Fast Ethernet 028 to 24, and with the command shutdown you are disabling these ports and they cannot be used on the switch. The simplest and the most effective method to prevent MAC address table overflow attack is to enable port security. Port security limits the number of valid MAC addresses allowed on a port. It allows an administrator to manually configure MAC address for a port or to permit the switch to dynamically learn a limited number of MAC addresses. When a port configured with port security receives a frame, the source MAC address of the frame is compared to the list of secure source MAC addresses that were manually configured or dynamically learned on the port. by limiting the number of permitted MAC addresses on a port to 1, port security can be used to control unauthorized access to the network, as it is shown here in this figure. And here the MAC addresses are shown as 24 bits for simplicity and for understanding. And see, it says that for the switch, the allowed MAC address for each port are listed in his MAC address table. And now the threads that try to reach the switch, they can not be allowed to have access to the network since their MAC address is not listed in the MAC address table. And we can use even switch port security command. The switch port security command can only be configured on manually configured access port or manually configured trunk port. By default, layer 2 switch ports are set to dynamic auto, which means trunking is on. And here in this example, the port is configured with a switch port mode access interface configuration command. So we have, for example, interface fast Ethernet 01, and this is switch port mode access. We use the switch port security interface command to display the current port security setting for fast Ethernet 01, as it is shown in the example. You can see that how port security is enabled. Port status is secured down, which means that there are no devices attached and no violation has occurred. The violation mode is shut down. And how the maximum number of addresses is 1. And this can be seen by this shown from the show port security interface. If a device is connected to the port, the switch port status would display secure up, and the switch will automatically add the device MAC address as a secure MAC address. But here in this example, no devices is connected to the port. After the port security is enabled, other port security specifics can be configured as it is shown here. So we can configure egging, MAC addresses, maximum violation. So let's see the configuring of the limit and learning the MAC address. To set the maximum number of MAC addresses allowed on a port, we have to use the command switch port security maximum followed by the value. The default port security value is 1. The maximum number of secure MAC addresses that can be configured depends the switch and the iOS. In this example, the number is 8192. The switch can be configured to learn about MAC addresses on a secured port in 3 ways. The first one is manually configured, where the administrator manually configures a static MAC address by using the following command to each secure MAC address on the port, as it is switch port security MAC address followed by the MAC address. We have the second option, which is dynamically learn. So when we use a switch port security command, the current MAC address for the device connected to the port is automatically secured, but is not added to the startup configuration. If the switch is rebooted, the port will have to relearn the device MAC address. And then we have even dynamically learn sticky, which means when the administrator can enable the switch to dynamically learn the MAC address and stick them to the running configuration by using the following command, which is switch port security MAC address sticky. Saving the running configuration will commit the dynamically learned MAC address to NVRAM. And here in the following example, we can demonstrate a complete port security configuration for Fast Ethernet 01 with a host connected to port Fast Ethernet 01. The administrator specifies a maximum of 2 MAC addresses, manually configures the one secure MAC address, and then configures the port to dynamically learn additional secure MAC address up to the 2 secure MAC addresses maximum. And by using the show port security interface and show port security addresses, we can see the command to verify the configuration. And all of those are shown here in this slide. The next thing about security at the port is the port security aging. Port security aging can be used to set the aging time for static and dynamic secure addresses on a port. Two types of aging are supported per port. We have the absolute and inactivity, where the absolute is the secure address on the port are deleted after the specific aging time, or as an inactivity, the secure address on the port are deleted only if there are inactivity for the specific aging time. Use aging to remove secure MAC address on a secure port without manually deleting the existing secure MAC addresses. Aging time limits can also be increased to unsecure past secure MAC addresses remaining, even while new MAC addresses are added. Aging of statically configured secure addresses can be enabled or disabled on a pure port basis. By using the switch port security aging command to enable or disable static aging for the secure port or to set the aging time or type. And the parameters for the command are described here in this table. And here we have an example that shows an administrator configuring the aging type to 10 minutes of an inactivity and by using the show port security interface command to verify the configuration. If the MAC address of a device attached to the port differs from the list of secure addresses, then a port violation occurs. So which means that now we are seeing the port security violation mode. By default, the ports enter the error disabled state. To set the port security violation mode, we have to use this command. Switch port security violation followed with one of the options, protect, restrict, or shut down. And these violation mode description are here in this table. And here we have the security violation mode comparison. Here we show an example that shows an administrator changing the security violation to restrict. The output of the show port security interface command confirms that the change has been made. But what happens when the port security violation is shut down and a port violation occurs? The port is physically shut down and placed in the error disabled state, and no traffic is sent or received on that port, which means that now we are seeing the port in error disabled state. Here in this figure, we have the port security violation is changed back to the default shutting down setting. When the host with MAC address as A41F72726768 is disconnected and a new host is plugged into fast Ethernet 01. We can see that how a series of port security related messages are generated on the console. And here in this example, the show interface command identifies the port status as R disabled. The output of the show port security interface command now shows that the port status is secure shutdown instead of secure up. The security violation counter increments by 1. The administrator should determine what caused the security violation if an authorized device is connected to a secure port. The security threat is eliminated before re-enabling the port. In the next example, the first host is reconnected to fast Ethernet 01. So to re-enable the port, first use the shutdown command, then use the no shutdown command to make the port operational, as it is shown here in this example. But after configuring port security on a switch, we have to check each interface to verify that the port security is set correctly and to check to ensure that the static MAC addresses have been configured correctly. So, to check the port security for all interfaces, we have to display port security setting for the switch by using the show port security command. With this command, we indicate that how many ports are configured with the switch port security command. And here it indicates that only one port is configured with the switch port security command. And for the port security for a specific interface, we use the show port security interface followed by the interface number. With this, we view details for a specific interface and all the kinds of security set up for that interface. To verify learned MAC addresses, if they are sticking to the configuration, we use the show run command as it's shown here in this example. And as you can see, for fast Ethernet 01, we have all kind of security configuration set for that interface. The maximum number of addresses, if the MAC address is sticky, which MAC address is learned, and exit time for the interface, if the interface will stay in activity for 10 minutes. And then we have to verify secure MAC addresses, which means that to display all secure MAC addresses that are manually configured or dynamically learned on all switch interfaces, we use the show port security address command as it's shown here in this example. And that is all the information about the port security and what kind of configuration we have to do to implement the security on a switch port or all the switch ports. So in the next material, we will go and mitigate VLAN attacks, DHCP attacks, ARP attacks, spanning tree protocol attacks. See you to the next session, and for those who are new to this channel, do not forget to subscribe and share the video with your friends. See you soon.